Welcome to this next lesson, and in this lesson we'll be treating covalent bonds. So we'll be treating covalent bonds. In the previous lesson we talked about ionic bonds, so here we're talking about covalent bonds. So let's head into the lesson. As usual, I'll start with an introduction to covalent bonds. So covalent bonds are bonds that involve the sharing of electron pairs, between two atoms. So it involves the sharing of electron pairs between two atoms to achieve a stable electronic configuration. So for ionic bond, the purpose was to achieve a stable, complete outermost shell. While for covalent bond, it's actually to achieve a stable electronic configuration. So they are trying to get a stable electronic configuration, and it involves electron sharing for covalent bond. While for ionic bond, it involves electron transfer. So as you're taking your note, take note of these things I'm mentioning. So this type of bond they commonly occur between non-metals. So unlike ionic bond, which occurs between metal and non-metal, so covalent bond occurs between non-metals, and it's fundamental for molecular compounds. So and also it includes essential biological molecules. So this is kind of bond that's formed between biological molecules that are formed in biological molecules rather, and also molecular compounds. So let's see the mode of formation for covalent bonds. So covalent bonds form when two atoms share one or more pair of electrons. Pair of electrons. So every bond would always made up of two electrons. Every bond would always made up of a pair of electrons. So for covalent bond, it could be the sharing of a pair of electron or a sharing of two pairs of electron. So I'm saying pair, meaning two electrons. They are sharing two electrons or sharing two or more electrons. So each shared pair constitutes a single bond, which is what I'm trying to explain. And double and triple bonds involve the sharing of two or three pairs, respectively. So shared electrons spend time around both nuclei, holding the atoms together. So when you see covalent bonds, the shared electrons means the electrons don't just stay on one atom that is involved in that bonding. So the electron that is being shared move around both species. It's just like as though we have someone having gari, that's in Nigeria known as eba, then soup, the other person having soup. So when they are trying to combine these two, when they are eating, nobody can say this is my own or that is my own, because both of them are benefiting from the union. So this kind of bond is a shared kind of bond. You cannot tell me, okay, the soup would be only for me because I'm bringing gari, or the gari will be only for me because I'm bringing soup. Both of them will have to use it equally. So this is the kind of bond that happens in covalent bond. There is a sharing of electron, meaning the electron would move across both atoms, the nucleus of both atoms. So let's see the types of covalent bonds. We have two types of covalent bond. We have non-polar covalent bond, and we also have polar covalent bond. So for non-polar covalent bond, this is where the electrons are being shared equally. So in non-polar covalent bond, the electrons are being shared equally. But in polar covalent bond, it means the electrons are being shared, but the sharing is not done equally. So it means that one of the species behaves like a bully, though they are sharing, but it seems like as if it's taking more. Just like the kind of thing that happens when maybe an adult is trying to eat with a small child, and maybe the small child has the soup and the adult has the same instance. One person has the soup, the other person has the gari. Then the adult then would eat more than the younger child, because normally their stomach is bigger and they have tendency to take in more than the child. So this is what happens in a polar covalent bond, where one of the species has a stronger electronegativity than the other species. So as a result of that stronger electronegativity, it tends to hold the electron that's supposed to revolve around both of them more. So this is what happens in a polar covalent bond. So these polar covalent bonds are formed as a result of presence of a species that has higher electronegativity, and this creates a kind of partial charge across the two atoms. So a kind of partial charge. So they would then have, instead of them to be completely neutral, they would have a kind of partial positivity and partial negativity across both species. So now let's see. This partial charge leads to what is called um, uh, um, a kind of dipole. So let's head on to the lesson to explain further. So properties of covalent bond, or covalent compounds rather. Covalent compounds generally have low melting and low boiling point compared to ionic bonds. So they have low melting and boiling point. Not generally, but comparing them to ionic compounds, they have a low melting and boiling point. Comparing to other compounds, they might have higher ones, but when you are comparing them with ionic compounds, they have a lower one. So they may be gases, liquids, or solids at room temperature, and they do not conduct electricity. So this is one characteristic of them. They don't conduct electricity except for polar covalent compounds. So they have a kind of tendency to conduct some sparing amount of electricity, but very small. But basically, all covalent compounds are seen not to conduct electricity. So in most cases, they often dissolve in non-polar solvents because they are usually non-polar. Majority of covalent compounds are usually non-polar. So some of them are polar, as I mentioned in the previous slide. Some of them can be polar, but most of the time you would always see covalent compounds to be non-polar, and they will dissolve in non-polar solvents. So examples of covalent compounds, we have water, and we have also methane, we also have oxygen, we have carbon dioxide. So these are examples of covalent compounds. These molecules, they illustrate various types of covalent bonds and also molecular geometries which influence their chemical behaviors. So bond strength and bond length. So in our previous class, I talked about lattice energy, and I was talking about how the distance between the two atoms nuclei can affect the strength, the lattice energy. So in this portion, we'll be talking about bond strength and bond length. So we're trying to see them in deeper details. So covalent bond strength increases with number of shared electrons. So meaning the strength of every covalent bond would be more depending on how much electrons are being shared between these two species. So unlike ionic compound, what determines it is charge. The charge of the species is what will determine the bond strength. But in the case of covalent, it is the number of electrons that are being shared, the electron pairs that are being shared, that determines the bond strength. So triple bonds, this is why triple bonds are stronger than double bonds, because triple bonds, they tend to share more electrons between the two species, unlike double bonds. So triple bonds will be stronger than double bonds, and double bonds will be stronger than single bonds. So covalent bond I'm talking about. So also, as the bond length is increasing, the bond strength is reducing. So when bond length increases, the bond strength reduces. So meaning, as the distance between the two nuclei become farther apart, it means the sharing, the same thing I was talking about for long distance relationship. As the distance becomes more, the relationship becomes weaker. So that's the relationship between bond strength and bond length. So you could see it in some questions and say which of these is true about bond strength and bond length. They'll tell you bond strength increases with bond length. That's wrong. Bond strength decreases with bond length. That's very true. So that's how it is. There's an inverse relationship between bond strength and bond length. So as bond strength increases, bond length decreases. As bond length increases, bond strength decreases. So let's see comparison between covalent and ionic compound. Let's see a clear comparison between both compounds. So unlike ionic bonds, covalent bonds do not involve full electron transfer. Rather, it involves electron sharing. So which was what I was trying to mention. Ionic bonds involve electron transfer, full electron transfer, while covalent bonds involve electron sharing. So covalent bonds, they do not form crystal lattice. While ionic bonds form crystal lattice. And these covalent bonds, they have more varied physical properties and chemical behavior, unlike ionic compounds. So the interactions between these species are governed by molecular geometry and polarity. So the interaction between covalent and covalent bonds are governed by geometry, molecular geometry, while that between ionic bonds are by polarity. So let's see, in conclusion, the covalent bond is a central concept in molecular chemistry. So mostly when you're talking about molecular chemistry, it's always like even organic chemistry is basically covalent bonds. So understanding how atoms share electrons provides an insight into the structure, function, and properties of countless substances essential to life and also industries. So this will be the end of this lesson, and I'll be saying goodbye.